So in this video, we're going to answer this problem. So copper wire of a known length has a diameter of 0.25 inch. So we have a diameter 0.25 inch and resistance of 0.28 ohms. Considering a copper wire of a known length. So by successive passes through drawing dies, so the diameter of the copper wire is reduced to 0.05 inch. Then, assuming the resistivity of the copper wire remains unchanged in the drawing process, so we have conditions. Determine the resistance of this wire. So we're going to find the other two. Conditions. One, assuming that the resistivity of the copper wire remains unchanged. So there's a drawing process. Also, we have the same resistivity assuming. So when you say drawing process means reshaping. I'm going to explain it later. So solution. As you all know, we have a formula of resistance in relation to resistivity, length, and its area. So we can solve this by doing a ratio and proportion of this equation with first and the second condition state rather. So R1 or rather R2 over R1 equals CBT of 2 T of 2 area of 2. Also 1 and area 1. Since we have this condition, so therefore they are equal, so we can cancel this out. So we only have left this equation. But however, we don't have a length, so we cannot still solve for the second value of the resistance. But since it was stated here that drawing process means reshaping, or when we say we have this conductor having area, cross-sectional area and a length. So the volume of this cylindrical shaped conductor will be equals to V1 equals area 1 times length 1. When we reshape this, so or reshape or the drawing process, example we have this area now, and we have this example now, visual representation only. So we have an area and the length is changed. Considering the cross-sectional area here is big and the length here is long, so the length here must be short. So therefore, 2 plus area 2 times 2. This is 1, this is 1, this is 2, this is 2. Since this conductor was only reshaped, so reshaped only, so the volume of this conductor V1 is just equals to the volume of this conductor V2. It was only reshaped. So using this relationship, we can manipulate this equation, multiplying, it's multiply area also on the other one. Since this is equals V2 and this V2 and this V1, we can put we can simplify the equation with this V2 over this A2 squared all over V1 all over A1 squared. Since we have this relationship, we can cancel this out. So simplifying the equation, this will go up, this will go down. R2 or R1 will equal to A1 squared all over A2 squared. Since the cross-sectional area of the circle will obtain like y terms of diameter rather d1 squared all over pi over 4 d2 squared. You can cancel out this and this when you simplify it, so it will just be cancelled. When you distribute this exponent pi over 4 quantity squared, so it will just still cancel as a constant. Therefore, the equation would be d1 squared times 2, 4, d2 times 4. So R2 will be R1 times d1 over d2 raised to 4. Plugging in the values, 0.28 ohms, d1 of 0.25 all over 0.05 raised to 4, calculated. So we have 170 ohms. And this, so as you can see this equation, 175 R2 is inversely proportional to its area. Given the area, no, diameter reduce. So this is reduced or to so this is the answer.